Com represents a transaction, with X the address at which the continuation or contract K can be reached, and Q the arguments for the contract. First, these components are going to differ depending on how we run our transactions, but yeah. So how I imagine it is that the arguments for the contract consist of at least these things. The arguments for the actual contract, the person or agent from which the transaction request is originating, a rev to phlogiston conversion factor, which I'll explain in a moment, an initial amount of rev, and a max for phlogiston usage. So rev is essentially the spending power that the contract has. It's similar to Ether and Ethereum. Yeah, exactly. The rev to phlogiston conversion factor is actually specified by the person who's sending out the transaction. Again, similar as in Ethereum. Max pH is the amount of phlogiston at which the contract halts. When this reaches 0, the contract has no more spending power, so it must stop. There's an interesting question. We hope to put out Mercury with a phlogiston estimator, a cost estimator. In the case that we actually do accomplish that, the max pH value will, assuming that it does give an actual max on the cost, will be the amount of phlogiston that the estimator suggests. So that kind of ties in nicely. So let's do a couple definitions. Let's just say, hypothetically, that the phlogiston equals, yep. So I'm going to just do a couple definitions. Give me a second. We'll be all right. Oh, gosh. Okay. Okay. Oh, yeah, sure. Okay. pH, phlogiston cost, and we're giving the max pH equals, let's just call it N phlogiston. Cool. All right. So let's just call PHC the cost of phlogiston. So that's essentially our rev to phlogiston price conversion. What we're saying is we get for this many rev, we get this many phlogiston, right? So if I want to specify, for example, that I want to make my contract very, very expensive, then I say rev or 20 rev gets me 1 phlogiston. Okay. If I want to make my contract very cheap, then I say, for example, 0.02 rev, get 1 phlogiston. The max pH value, like I said, is the estimated value where N. Who gets to choose the conversion? Oh, good question. Excellent question. The agent that proposes or that requests that the contract is run gets to produce the conversion. Yeah, so for those unfamiliar with exactly how Ethereum does it is the person who's requesting the contract is run suggests a conversion factor. The miner, based on that conversion factor or determines the amount of rev that the contract actually requires to run. But we're free to change that, and we're free to alter the conversion factor because if effectively what we'd have, we want to allow the person who's running the contract to specify, the conversion factor.
Service. Definitely run my contract, or when you get around to it. It's like a bid.
Right, it's like a bid, yeah. And the more expensive that we the more expensive that we make phlogiston, the greater potential rev there is left over at the end, so the greater potential reward there is for the miner. The cheaper we make phlogiston, potentially the smaller reward is left for the miner. So let's just say that our max phlogiston, right, is equivalent to N. For N steps that exist in the contract, that's what we have. So the total rev or this value that we're actually going to get is going to be rev equals PHC times max pH, noticing that our units cancel. So that's kind of how these are calculated. So phlogiston is actually different from Ethereum. It's a four-component, it's a four-component kind of structure. So the components are compute, memory, storage, and network. For each of these, they represent the amount of some resource that is consumed during the lifetime of a contract. For compute, let's just consider, for example, that everything costs the same amount, right? So for n transitions or n actions that my contract takes, I have a cost of n phlogiston in the compute component. No?
If you multiply those out.
Right, then you multiply them, phlogiston cancels, we get rev.
No, you get rev times n.
Oh, sorry, this is just a unit annotation. So we get, all right. Yeah, exactly, it's in, like an
right, I believe max is n, yes. But that's not what your upper right, the upper right just confuses me.
Max phlogiston, cost of phlogiston, right? So we have n phlogiston, that's how many we're going to spend.
Right.
And at a cost of q rev per phlogiston. So when phlogiston cancels, we get the amount of rev that it's going to cost.
Equals NQ, right? So that simple as, if you just write then rev simple as NQ, then that's more clear.
Oh, sure.
Right.
Okay. Oh, gotcha. Yeah. Good observation.
Shouldn't it be we get like a greater than or equal, not an equal? The rev has to be at least.
Right. I guess. Assuming, I suppose you could.
Well, if you don't, if it's not, if it's just equal, then you don't need the field. You just recompute it.
Say again.
If it's just equal, then you can just recompute. You don't need the number there.
Yeah. Well, assuming again that the rev or the phlogiston that was specified was the one that our estimator gave, which is the absolute maximum, you wouldn't need anything greater than max pH. So under that assumption.
So I understand max pH and Q there as being the amount of gas allocated, or the amount of phlogiston allocated.
Right.
And rev, the amount of money allocated to pay for that.
Right.
And so if you allocate it at a price and you don't have enough money to cover that, then that's like an invalid transaction, right?
Right, which we would check for.
Yeah. Okay. So then you don't. So before I was thinking rev greater than or equal to that stuff, and now you have NQ rev, and I actually lost. I don't know what that means anymore.
Oh, that's because all right. So Q is the amount of rev per, and N being the amount of phlogiston that we need. So N times Q, assuming these would be the specific amount of rev that we needed.
So you're missing an equals there. NQ equals rev equals.
Denominated in rev. Sorry.
Oh, it's a unit. Okay, so there's a unit there, and then over there in the Q, that's also units.
Yeah,
okay.
Exactly. Yeah.
I thought it was like a variable name.
No. That would be extremely confusing. Yeah. Totally. Okay. Cool. So back to it. Compute is the cost essentially of the actions that we take that change the state of the contract. So let's just imagine that actually let's use K. K prime, and let's just say, can do L to go to K prime. Don't worry, I'm not going to go into it. Memory being the spatial cost of how much memory we occupy during the execution of the contract. Obviously, we're going to want to keep track of that. Storage is actually a different component that's got some interesting side qualities to it. But during execution, the costs that we have to keep track of are CM, and this last one, which is network. Network is, of course, the it's a component of phlogiston representing the amount of network access that the contract consumes. So let's just say, we send something over the wire, 5 times, and each time we send over the network, it has this cost. Well, obviously, we're going to want to compensate for that cost. So again, dynamically compute, memory, network. Storage, however, is a component that's actually persistent, and it's because we lease, or we actually have to compensate node operators for their storage over time, right? And on Discord a while back, there was a question that was posed, which is, if storage is a long-term cost, then how do we protect people that are storing their contracts on chain from price swings in Rev, right? Because if I specify only in Rev and it costs 5 Rev a month, well, compared to another currency, that could be a massive price difference, right? So we have to provide contract owners and people that are leasing storage the ability to specify a neutral amount. And to do that, it's actually super simple. It's just like an algebraic kind of manipulation. So say, for example, we specify a persistent conversion factor, Rev to PH. This doesn't exist necessarily in the contract arguments, but is available in the contract data in storage. And we say that storage costs this much, phlogiston per month or per whatever period, right? Then the amount, it's actually really easy. So to calculate the amount of phlogiston that we're actually going to need in a neutral way, all we have to do is say right. So I should probably give those different names. It might be kind of confusing. But let's just say that max pH now represents the amount of storage, the cost in phlogiston of storage that someone says, whatever a node operator says that they want to charge per month. And we know that it's going to take up this much storage maximum per period. And let's also say that PHC is a... let's also say that PHC is a conversion factor that we're going to set and that we're going to let persist. So over this period, the Rev to phlogiston pricing is going to be at this ratio. Well, we know then simply that if, just by kind of dividing by the max pH and dividing max pH by the price of Rev, we can just get the phlogiston amount that we're actually going to need, or the phlogiston conversion factor that we need. So with a max pH and a Rev price per phlogiston, we can calculate the ratio that we need to exist so that as price swings take place, we can kind of recalculate that so that it costs the person hosting the contract the same amount over time. And so they have kind of a guard against price swings. Let's see. Right, I guess the other thing, or our talk was pretty much divided into two components with respect to economics. We talked about dynamic enforcement of phlogiston pricing, and we talked about static estimation. So I suppose we could talk about the runtime enforcement. Now, I'm not as familiar, and I think we're hashing out a lot of this week about,
The price swings thing, what price swing are you trying to protect the contract?
The price in Rev, right? So if I want to be able to specify a maximum amount that I spend per month on storage of my contract, right? And I want...
So I'll agree to pay 5 Rev on October 1st for the storage for the rest of the month.
Sure, and I know how much storage I'm going to use, right? Okay. So I want to be able to say that next time I'm being charged for storage, I want to be charged at this conversion ratio, so that I can change exactly how much phlogiston per Rev that I get with respect to price swings in Rev, so that when the Rev price goes up, the cost of my storage doesn't skyrocket. It's optional.
Global ratios getting used here? As in the environment
Oh, well, actually, I was thinking that could probably be a namespace policy sort of thing. So,
And the inexpensive 5 Rev
Exactly, right. So regardless of price swings in Rev, I can get a consistent cost of storage, right?
An alternative is to simply have to go renew your contract and you negotiate the new price the next month if there's a big change in.
Right. Yeah, I was simply proposing it as an option.
I'm confused why anyone would run a contract. Why would any system provider agree to operate a contract where they were guaranteed never to have any upward exposure to the price of revs, right? And why is consistency of the price of storage thought of in terms of some external currency? It's not rev.
Well,
right? If you and I negotiate to pay for storage at the rate of 5 rev, right, at the end of the month, I want my 5 rev. Right? I don't want to be told that actually it should only be 1.2 rev because, rev did something relative to Bitcoin. Like we didn't have a contract in Bitcoin, we had a contract in rev.
Right. So can I, and then, or you? Okay, no, yeah, please.
I'm sure you wouldn't want to have 1.25 rev instead of the 5, but the person who's paying for the storage would rather pay the 1.25 than the 5. And then the question is, you're trading off interest here, right? Price stability for the spender in terms of US dollars, or is kind of like what this can achieve, right? You're saying, okay, well maybe they don't need that because I would rather have exposure to the price of rev. And my gut reaction to that is like, well, who are you serving? Are you serving the miners or are you serving the users?
Exactly. Yeah.
Well, I mean, that might be a conflict of interest. Wait, but really, that might be a conflict of interest. You should really note that might be a conflict of interest. It's like really a conflict of interest. If you are thinking about influencing the design of the protocol in order to pay out yourself more.
Right. Okay.
Yeah, that's exactly the argument I'm making. Is sort of like at the end of the day, the way business actually gets done is that you negotiate a contract up front, and each side has to deliver something, right? So, in the case of a smart contract, you're saying here's the thing I want you to execute on your computer, right? And if you execute this, then I will pay you. And so you're going to pay me, and I'm going to execute your thing, right? And we agree on the price up front, and then at the end, when the contract closes, right, I get paid what we agreed on, not some negotiated amount that's
maybe.
One second. Paid in dollars,
hold on.
Negotiate your contract for dollars.
That's right.
Yeah.
Right. So you can say that it's like a conflict of interest, but at the end of the day, I just want to be able to operate machines that run the network, and I want to make enough of a profit that I can stay in business and that I can make the network really nice.
Totally.
For you guys,
here's also
right?
All right. So
it's not. Wait, hold on, because it's not a function of like the contract's getting more expensive, right? The contract is 5 revs, right? The fact that 5 revs might be worth more after some period of time than it was at the very beginning when you submitted the contract, right? That's sort of the way things go, right?
Sure. Okay. So one second. All right. So here's the thing. All right. Hold on.
This is definitely true for dollars, right? When dollars exchange for euros,
the dollar drops with respect to the euro. You don't get paid more dollars.
Right.
You negotiate your contract. In the contract, you specify the currency that you're using to pay for it, and then you just pay it.
So, if you want to make sure you have consistent costs at the end of the month, you could always pre-purchase now the rev that you're going to spend at the end of the month, and you have locked it in.
Right. So even providing the option is, it seemed like a reasonable thing to do because providing the option at. Oh, sorry. Oh, whoops. All right, cool. It's because I take my shoes off. Yeah. Okay. Maybe we don't want to allow an adaptive rev to phlogiston price because in rev or in USD, we want to have a consistent price, right? That is a totally valid point of view for some people. From some hold on. For other people, right, for a lot of contract owners, we would say that we would not like if the price of rev went from 10 cents to, I don't know, $20 in one day to, I don't know, back down to $14 the next day, that my contract gets astronomically expensive. And especially for industrial scale applications, that could, that could severely affect the ability of average users for running their contracts. Also,
it comes to denial of service attack. So if the contract is implementing core application logic for some massive application,
right,
then the denial of service attack on that application is to drive up the price of rev. And now suddenly all these users are disenfranchised.
Right, and consider...
But you guys say the price of rev as though it has one price. It's the price of rev with respect to dollars or with respect to euros or with respect to Bitcoin.
With respect to the user
audience. So if you
audience.
want it to be stable in a particular currency, you make the contract in that currency.
Okay, but all right, let's not pretend that these currencies have any sort of stability about them. Let's not pretend that if I'm a whale, that I can dump 50% of my holdings and crash the price of Bitcoin. They're not going to be stable. They're not. I mean, they're just not. So let's not pretend like they are. Also, hold 1 second. Hold on. Also, let's consider the fact that this sort of this granularity in complexity compensation hasn't really, at least that I know of, been done before. So there is no precedent here. So providing an option for it to go either way, I think, is a responsible way to design a system.
I think you have a precedent. If you look at the normal contract, you have a time and material contract, and you have a fixed price contract. So you are what he's saying fixed price and what he is talking with the TMF, right? So depends on how you set the rate based on the exchange rate to something I don't care about.
So if I can jump in here, so I think it helps to separate cost and price, and note that it does depend on you operating in the U.S. and me operating in the U.S. denominating stuff in dollars. We do that because all of our costs are in dollars, and dollars don't fluctuate relative to dollars. They might fluctuate relative to rev. They may fluctuate to euro. So in forcing everything into rev or some other intermediate country, you force everybody who doesn't want to deal with fluctuations to deal with fluctuations, and that is going to be a challenge to adoption.
Yes, that was the issue.
And the having this price there exactly removes that, right? We're not forcing anyone to price it in terms of anything, right? We're giving people the right to bid in order to create like a some kind of market signal, right? And I think that the important thing to note about all this is that the reason why we use US dollars for deferred payment is because it reduces our transaction costs, right? The reason why I don't want to lock in the price in rev is because that is a higher transaction cost. It's actually cheaper to hedge the price of the price of rev, the price of rho, than it is to hedge the price of rev. And that lower transaction costs is really the thing at the end of the day. Like you want to negotiate deferred payments in terms of something that is, as cheap as possible for you to hedge.
I don't think you can say cheap at this point, right? I mean, market is taking the price and then market is deciding. So what I hear from here, the conclusion, what anyway Roland already summarized, I mean, there are two types of contracts, whether you want to follow, you guys are forcing adaptive contracts, or if I want a fixed price contract, right? I mean, that's what is happening.
We're not forcing anything. We're providing it as an option. I mean, just as anything. That's what I said. I said it was optional. You just specify your policy. I said this at the beginning, that it was an optional. It was an optional feature. So. Oh, whoops! All right. I didn't know that one division operator could cause so much conversation.
So this goes back to my point at the top. When I opened the sessions this morning, was we're in this crazy world where you can't do software architecture without doing economic architecture at the same time. I mean, it's down to, this is what Joe was talking about here. He was about to talk about what goes into the information in the COM transaction record that nests inside the blocks that we were just talking about, right? And that's what touches on this discussion. Wow.
So I think what you're doing, you're hedging into your equation itself, right? If you look at the normal people, most of the people
How are we using hedging here? Just if I could.
Today, you are doing signing up an adaptive contract today, and you are hoping that from month now it's gonna cost me less, right? I mean, that's what you are banking on.
We're saying instead of banking on that.
No, that's
what you have. So instead of banking on the price being fixed, right, or instead of having to hedge the price of rev, right, well, instead what you get to have is this indirection between the price of flow and the price of rev.
So, okay, let's step back. So at this moment, if you think there's no fiat currency involved in this equation, there are only two parts involved. One is the rev, another is the flow resistance, right? I mean, do you think there'll be...
Put the microphone near your mouth.
Good point. So if you have only two, phlogiston and rev, then there's no fluctuation in income. Most likely it's gonna stay same. The ratio between them is gonna stay same.
Why is that your assumption? Why do you think that's most likely?
I think you have a good point. Probably I may be wrong, but in this case, yeah, the fluctuation may not be that much. I think that will depend on the usage of the network, usage on how much people.
At the very least, it's going to be a supply and demand thing, right?
Yeah, probably you're right. It spikes
because at some points people want to buy a lot of flow. At other points, they don't need to pay for as many computation, storage, whatever.
So my problem with this is if I pay a contract in rev, I understand that. I don't understand what the phlogiston price is or where it comes from or how you get it. But if I sign up, if I agree to store your stuff for a month for 3 rev, I understand that. Like dollar price, which dollar price? The dollar price at the mall or the dollar price at the exchange rates, right? Like the bid or the ask. But if you do it in the native currency, that I understand.
Yeah, but the price of flow is in the native currency. The price
no,
of
it's
flow
not. The
will
price
be,
of flow is
denominated
in every
in rev.
transaction.
But it's denominated in rev.
But you're suggesting that you'll adjust it post hoc based on what
It absolutely
the market's
will adjust post.
There isn't one price of flow.
Of course not.
We just wrote it down. There's every transaction in a block has its different price of flow. And so which one of those are you picking?
Okay. So again, let's make a distinction. And this is I considered rewriting the names of these variables for time considerations, but now I see that wasn't a problem. So the rev to phlogiston, right, is a price that we get, or is a conversion factor that we have that applies to, in this case, to the cost of compute, memory, and network, which exist on a per transaction basis during the execution of the contract. A price that we can set that's persistent, optionally, is a conversion factor, right? So I know that if I set this conversion factor, that in rev I'll get, or in the denomination of rev, I'll pay consistently $5 if I want to denominate rev in dollars for storage per period, right? That's what this comes to. Is like I could give rev in the price of USD per rev, right? So I mean, what's as a user,
how do you do that? I mean, so here's the problem. So what I think you guys are doing is that you're trying to make rev make sense in terms of what you already know, which is dollars, and you want people to feel like the prices the prices of the contracts aren't changing in dollars, even though rev is fluctuating highly. And the reality is that like there isn't even a rev to dollar conversion without a book, right? Because you have to have a market.
Totally.
Right? And so there have to be transactions closing for rev to dollars in order to set a price. And there's no canonical way to do that in the economy. So when you denominate smart contracts, they need to be denominated in rev. And what you're doing is you have to decide, the contract owner would have to decide, like, am I going to pay you up front and then risk that the price of rev may rise and I will lose out on the gains? Or am I going to pay you on the back end, the price of rev, may, go down and I'll have problems or whatever, right? And what you're trying to do to control costs for people is pass all of that risk off onto the node operators, right?
No,
and it's market risk. It's not, that's not a reasonable way to architect the system.
Okay.
Yeah, it is.
Okay.
We didn't talk about any of this
Listen.
during the session.
Yeah.
Not summarizing what we did it.
Yeah.
Surprise!
We have half an hour.
Okay.
So
Is this the second group or the first? Third. This is the last one.
Am I the only one who's like really confused here? Because
No, clearly not. I think.
So would it help? Would it help if we? Okay, because to your point, a lot of us understand dollars. Could we walk through this, a storage model, in contract model in dollars, and show how that figure is stable? Because, like I said,
No, I don't think we should do.
First of all, I just want to say it's not about thinking in red versus thinking in dollars. What this is about is recognizing the fact that you have a certain market size at one point. The contract writer is not just writing for that market. The contract writer is writing that market for an imagined much bigger market that they would like to come in. And so if suddenly their storage price balloons with respect to this market that hasn't made it over to rchain, right? Then they're hosed. They got no market, right? So what he's trying to do is to allow for this shift, right? So imagine rchain suddenly, so rchain launches next year, and it's working as advertised. And there are a bunch of really cool contracts where people can do interesting stuff against the virtual machine. Now, people could have priced those out in Rev, and suddenly the rest of the internet finally hears about rchain. Okay? Now they're out of the market. Nobody can even touch those contracts because nobody has in their hand a bunch of Rev except the people who got in at the beginning.
It becomes no entry point. It becomes impossible for me as a new user to be able to afford to run a significantly complex contract. However, one second, I just want to note, right? So this is a conversion factor that's proposed, right? In the same way that a miner doesn't have to agree to run my transaction if my rev to phlogiston conversion factor isn't suitable for the miner. They don't have to agree to keep storing your stuff in their storage layer. They don't have to, right?
Yeah. So then, so one thing that can happen is that
I could just say sorry, this isn't enough per month.
Yeah.
Right. Yeah.
Exactly.
It seems like all of this argumentation can be solved based on not the smart contracts, but the contracts between the author and the node when they go up. If they want to isolate themselves from future fluctuations in the price of rev with respect to dollars, then they pay up front. If a node user a node runner wants to prevent the price from dropping, he says, well, I expect you to pay me for at least 6 months of usage, and then we go to month after that. All of these kinds of contracts can insulate various parties from various kinds of fluctuations, and we don't have to build any of that into the deployment spec up front. So all of that can be handled in these individual contracts.
So I mean, that would be closer to true if a transaction blockchain actually was like a single payer and a single payee, but it's one to many, and that many is changing over time as the validators change over time. So if I negotiate with you and you later get rotated out for another validator and they're stuck accepting your rate, that's not fair to them.
So as far as rates go between multiple validators, then you achieve consensus on what that particular namespace is going to
right, and I think that's exactly what we were kind of talking about earlier with respect to like seeing whether there would be a price for rent that would dynamically change over time. That's like a consensus mechanism that agrees on, and basically is like will be the terms of the agreement.
And all of that seems doable using the smart contracts to set this up, and isn't something that needs to be decided here and now in how to deploy a contract.
But in any case, if you're going to say, oh look, like 4 slots of storage for 32 bytes, the same as like 1 slot of memory, then you're going to have to say something about like what is one flow, right? Like the flow needs to be identified, and a rev is something else. So we're really close, anyways.
Right.
To saying that
So
there's a price
let's
of
also consider,
a price of flow.
for example, that we want to set the conversion rate. I mean, just to get more simple in terms of, in terms of USD, right? So I mean, yeah. So if I want to say that this is going to cost me 5 USD per month, right? Well, I mean, the amount of rev equivalent to 5 USD is going to vary, right? But 5 USD is still 5 USD.
And the meta level discussion here is, I actually think this is fantastic discussion because it makes us much more aware of how all of these different things are impinging upon our architectural choices. And that's why I think this is a super, super valuable conversation.
I was just going to say that if you want to charge 5 USD, then you agree it is the price at this time on Poloniex for the exchange between USD and Rev. When the contract deployer on the node...
Right. At the renewal period.
Either the node that is running the contract or the set of nodes that are running in the namespace that concerns you and have agreed together on this thing. You make a contract with the set of nodes that's going to run your contract, your smart contract rather than your
right. So the only difference between denominating in USD per rev or in rev per phlogiston is that it allows us to get a little bit of uniformity, right? In the same way that the cost of sending Q, right, to a corresponding 4 is going to have a uniform cost, yet the price conversion of rev to phlogiston is going to vary. We could say that storage has a uniform cost, right? And the only thing that's going to vary is the rev to phlogiston conversion. So it's the exact same thing that we do during execution, right? The only difference is that during execution we don't have to worry about price swings because you set the price of because you witness the price of rev at the time that the transaction is started.
So,
now,
just to be clear, I just want to be, so when you talk about storage and you talk about rent on storage, we're talking pure on-chain storage, right?
Yes.
Every single node that's operating in your namespace is required to store this data.
Yes.
Right? And so this is not like this is not an off-chain storage service where you're writing
we don't need to worry about
contract
that.
for with some third party and you're just representing what's going on in the chain. Right?
We only care about what's on chain. Yep.
Now,
so it strikes. I mean, it just at the end of the day, right? Like, if you have to tie your on-chain contract prices to a market, right? Where is the book for the market?
Every transaction. The only one we have is the, say, average phlogiston price for the last 1,000 blocks, something like that, right? That's all in network. It's totally
that's not
identified.
in dollars.
I don't care about dollars. I care about price
But
fluctuation.
all he wants to talk about is dollars.
He cares about price fluctuation. I think also dollars is the easy example. So let's just keep it in rev over phlogiston, right? Take that average phlogiston gas price, right, over the last 1,000 blocks for this namespace. And you can shrink and grow that as an economic lever for whatever reason. I don't know. This is as much as I understand the economics I've learned today.
Now, one of the things that came up that's a subtlety is the notion of transaction. There are the race conditions that Casper is coming to consensus on, but the notion of transaction was I send a message and the contract spins its wheels until it's done spinning and then stops. If there's not enough gas, there's the potential, if you just cut it off and stop running, for you to break your security invariance in the contract. And so there's the potential for attacks where you don't provide enough gas to run it in order to break the invariance. And so then we have to talk about rolling back transactions and how that interacts with oracles. And this becomes more interesting than merely how much we're charging.
So two part, one part is comment and second is the question. So even though the price for storage is not changing, but ratio is changing, invariably it's the price for storage is changing. That's the comment. And the second, is there any ceiling? Now let's take an example, right? In the beginning, I signed up for
10 revs for 10 megabytes with one storage for a month. So is there possibly that ratio may go up, and then my contract may not have enough revs in it, and it can be discarded, or the person who is holding on the other side can say that your contract doesn't have enough money, we can't honor the contract. What's going to happen? Is there any ceiling or any bottom? For the ratio?
Just to make sure I understand, you're asking if I set a cost for storage and then the price of rev goes up, assuming that we don't have an adaptive price, is there a point where I run out of money and someone?
My assumption is we are going with adaptive pricing.
He was saying if you have adaptive pricing and the price of rev goes down, you could be cleared out. You have the exact opposite problem. Right, like you committed 1,000 rev, but rev tanked, and so now like it's all gone, and your contract gets deleted. Right. Is that a fair summary?
Yeah, I mean that's what we don't want, right? Your contract becomes delete me if that's possibly, then that's
and for what it's worth, right? Like whales can manipulate the price in both directions, right? So if you construct a system that prevents manipulations in one direction from affecting one group of people, then they'll just choose to do the opposite, flip the sign on what they're doing and manipulate in the opposite direction so that those people get wiped out, right? So, one of the things that's appealing about blockchain economics in general is that you can de novo create an entire ledger system denominated in the currency that you just create out of thin air and say, we're all going to transact in this for the purposes of building this network. Right? And then the network operators get to take the risk on whether or not that it will be long-term profitable or whether it will be a long-term cost to them, right? In terms of whatever currency their bills are denominated in, right? Altering those dynamics by trying to tie, prices and stabilize them, I think is, it's very fraught, right? Because you could very easily drive node operators away from the chain because they can't write a business model that makes any sense.
So, I mean, the whole point of this indirection is to give them that freedom to do the thing that makes sense. I mean, this allows you to change the price that you're paying for flow if the price of rev goes way up or way down, right? It gives you the freedom to price flow independently of the price of rev.
Right, and the point, in recognizing that the cost of the actions, right? So the cost of the operations, the cost of memory, the cost of storage, the cost of network are uniform. That's the only reason this works.
That's not true.
Yes, it is.
Why would you think that's true?
Because that's how. Why would I?
Why do you think the cost of compute and network and storage is uniform?
Propose an alternative. There's no way to do it there's no way to do it accurately in any other way than an abstract interpretation of cost if we want it to be uniform.
So I mean, I wouldn't say that. I would make an even weaker claim, right? If people's cost basis for their actual expenses are in dollars, then the price of flow in the price of flow will be less correlated to dollars than the price of rev. Because the bids that people are willing to accept are presumably only going to be the ones that are above their cost basis. And since their cost basis is in dollars, the price of flow that's priced too low will be excluded. And that will, and the price at which it's too low will be a function of the actual price of rev.
Okay, but that's not how a business operates.
Sorry, business,
right? So
don't have a cost basis?
When you build capacity in a data center, right, you're very often willing to accept prices that are below your cost and OpEx basis because you don't have anything else to run there, and the thing is on anyway, right? So you're not going to exclude productive work that you can do if because you can't just make those machines go away, right? I don't have my capacity in my data center. It's not elastic, right? Right? It's fixed. I have to plan ahead of time. I have to plan a 3-year business plan to deploy a machine in my data center. And that has a CapEx, it has an OpEx, and it needs to produce a return. Now that return does I'm willing to accept work for that thing at fairly low prices if there's not a lot of work out there, right? when the work comes in and there's a lot of demand, I sort of expect to get paid pretty good, right?
It doesn't get paid better than when there's no demand.
I would hope so. But what I'm hearing here is in the condition where everybody floods in, like I'm gonna take it in the shorts.
No, that's not at all what's happening, right? In the
Yeah,
condition
yeah,
where
it
in condition where everyone floods in, even if the price of rev is fixed, you're going to be able to have a higher income because people are able to compete with each other on the price they're paying for flow. So even if the price of rev is fixed and the demand for transaction increases, you can be paid more in this system, but you can't if you say the price of flow is fixed in rev.
Greg literally said that if the price of rev goes up because everyone floods in, then there's a difficulty with people acquiring enough rev to get their jobs run.
I mean, that's a separate other thing, right?
Which is the exact condition in which people who are operating nodes make the most profit, right? The condition where there's a shortage for their compute, right?
Well, the shortage of the compute isn't the same as the price of rev going up. Those are independent. Those are potentially independent things.
So what happens is, so think about it. What happens is that there's all this promise. The price of rev shoots up, and then none of the promise materializes because nobody can enter the market.
Because if you price flow as a fixed price in rev, then the price could literally just get too high.
But if the price of rev shoots up, you would presume that new contracts would be negotiated at lower prices.
So every single transaction is one of these negotiations.
That's what I'm saying. That's what I'm saying.
Every single transaction is placing a bid on what these price might be.
And for storage, as the price goes up, we can renew whatever our conversion.
So people won't need a whole lot of rev to create a new contract because the price of storage will have gone way down. It's just the previously negotiated contracts that we're talking about. It's not new contracts. New contracts will already be handled by the price fluctuation.
Well,
it's
because
just existing contracts.
Because price fluctuations don't really affect new contracts yet.
Where it's Byzantine general problems. Like nobody wants to write the first contracts because they know they'll never get that right.
No.
If they just have dynamically adjusted rent prices. I mean, it's kind of common sense that the price of rent should be has to do with the front price of flow.
It's straightforward, right? If I buy the rev I need now and buy the contract and I agree to pay the rev in a month, right? Like, well, I'm insulated, right? Like if rev shoots up.
All right, yeah, but what is the cost of the contract denominated in? Because if the cost of right, okay.
Yeah, so you can the way that prepaying rent works in like this kind of system where you actually have a price of rent is there's a bound on the most the rent could possibly be, and you prepay by paying the maximum price of rent in the future today. So you don't prepay now at the price of rent now. You have to pay the maximum price of rent. Otherwise, you can end up in a situation where people are being disenfranchised by serving your contract.
Right, because all right. So assume that what you're saying. All right.
So
the price of rent isn't fixed over time. If you want to pay upfront for rent now, you need to pay enough to cover the fluctuating cost over time.
And you can't.
No. Like if.
No, there's no dollars here. There's just
you can insulate yourself from price changes, right? Like monthly rent, you pay. You purchase the rev that you're going to need at the end of the month, at the beginning of the month.
Mm-hmm.
Right, yeah. That's what he's saying.
Yeah, that's what I'm saying.
No, but there's no max. You don't have to buy it out. Like,
the price of rent might be lower than you're projecting at the end of the month, right?
Yeah. The cost of storage.
Well, that's the cost of hedging, right? You want to avoid fluctuations. You just buy it now, and if the price goes down, well, you lost from hedging. That's what hedging is.
So yeah, and I mean, like if you want to pay now for all the rent of the future, you're gonna end up paying
not all
more.
The rent in the future, just all the rent you've contracted for the following month.
Yeah.
So all right,
sure. So you pay 1 month at a time, and you're gonna if you want to be sure that you're paying enough, you're gonna be paying more than if you pay as you go.
All right, okay.
For the next month, I, as a node operator, will charge you so much rent.
So, but you're not the only node operator on the other side of that transaction.
Well, it's all the node operators.
They came to consensus.
Exactly. And so what I'm saying, and what we're talking about is how
that
pricing should work. Right?
Hold on.
And that pricing isn't going to be a fixed pricing, because if it's fixed pricing, then we have these issues that we're running into over and over again, right?
No, I don't see the issues.
The issue is that
you do a fixed price for a certain period.
Yeah,
if you are concerned
a block.
about vast changes in the price of
the
rev with respect to some other currency, you shorten the period.
But then you're only limited to short durations of storage. Like you can only short You can only short. So you only want people to store things for short durations. That's what I'm saying. No, but they can pay a dynamic price. And not prepay everything.
The price at renewal is the dynamic price.
Which isn't known up front.
How about this? Okay, consider this. If we're considering that our problem is that we're hosing miners, right? That seems to be the general objection here, is that miners would get the short end of the stick.
All full nodes.
For example.
All full nodes.
Say again?
All full nodes.
All
full nodes get the short end of the stick.
Right. Exactly. Okay. So all right. So now. Okay. So. All right. Okay. So if that's your argument, consider the following situation, right? If
Go on.
All right, so consider this. Consider it actually depends on which direction the price goes, right? Because if I say right now, if I consider right now, just let me respond to this last one, then we'll table it. All right, so whoever, all right, so assuming there's non-adjusting pricing, who gets hosed is a matter of which way the price swings. If I say right now that the price of storage is 100 rev, and that's cool. So someone pays me 100 rev, right? And now let's say that, I don't know, I sell that rev immediately, okay, and then the price of rev drops, right? Well, then the person who's paying for storage just paid I don't know how much rev for storage when the cost of rev is now on the floor, right? Yet I, as a node operator, have sold that rev already and, kind of laughed to the bank.
But if you allow the variable price, then no one needs to take that short end of the stick.
But I don't see the I just don't understand where the variable price comes from.
Okay, all right, you're right. I think, and the reason that we never...
Because flow is different than rev.
All right, you're right. Okay.
We'll have to talk about it more over cocktail.
Yeah, great.
All right. I think hedging needs to be something that's done on the side, and you negotiate contracts in the native asset. I don't think putting hedging in.
There's more that price in it. Does it cause hedging? Does it create hedging? It's not.
That is hedging.
It's not hedging. It's literally a floating price. Floating prices are not by themselves hedging.
Stabilizes the price. Because if you have a...
It stabilizes the price in terms of a different asset.
No, it doesn't. But even saying that is potentially causing the issue, right? Because when you say stabilize price.
Okay, so the other thing we talked about was type system. The type system that Greg and I have been working on for a decade is not going to go into Mercury. It's too big and not quite done yet. So one of the things that we can get into Mercury is a simple sorting. For this, we take Java primitives like int and double, etc. And then we have, so S is one of these, or channel type of S. Right? So it's simply, yes, and this also has directionality, so in, out, bidirectional. And I think there was one more thing, but I can't remember offhand right now. So you could say this is something that receives, this is a channel of channels of in-ints or something like that, right? So that gives you a nice way of reasoning about the data that's flowing across the network. One of the things that we talked about is, well, what if I want to send a tuple? So then do arrays and maps and those sorts of things count as among these primitives? Now, there's been a proposal, Archon, for rchain object notation, kind of derived from JSON, where you can define a process that says key bang value pipe, say value 1, key 2 bang value 2 pipe, etc. And then if you send this on a channel, then the receiver for y from x, P here receives the name of this thing. And so then you can do a destructuring match on the structure of this process And it's a really nice way of doing a map, because pipe is commutative. So these are unordered key value pairs. It's a nice map. In fact, it's a multi-map because you can do key one bang multiple times. So this is interesting. We can also take something like 0, 1, 2 and desugar it to at 0 bang, let me do 9, 3, 7. So then at index 0 we have 9 comma, or pipe at 1 bang 3, pipe at 2 bang 7, right? So there is this way of desugaring these basic product types into RSON. And then we can also do tagged unions where we're sending pairs as our product, forgetting the notion of a disjoint union. So now we have products and sums, and we can embed an algebraic data type. But these kinds of algebraic data types don't satisfy Greg's desiderata of being able to iterate over them. So he wants, from an array, we would like to be able to say for x sequentially from 9, 3, 7 p of x, right? Where this gets 9 and does something with it, and then sends an acknowledgement back, and then gets 3 and does something with it. And we do have a desugaring for the sequential arrow into the linear arrow here. But how to equip an arbitrary data structure with these iterable types? How do we add methods like reverse or sort or whatever to these data structures? That's something we're still trying to work out. These are the syntactical issues that we'd like to consider. We also have things like for x equals 5 as a binder for being able to use a variable in an expression below. Lots of different kinds of arrows, what exactly they mean, how to equip them with the other methods that we would expect of a data type. When we get into iterables that don't have an obvious structure, say I've got a binary tree. Well, do I do it in order, pre-order, post-order, depth order? What are we doing for iterating over those? Each of them needs to be specified in its own way. So coming up with a data type specification language is something that has to happen if we want to be able to use these as richly as we would expect in other languages. Now, if we don't need all of that stuff for wallets, maybe I expect we would need a lot more of that sort of stuff for the Casper level. So this is something that we discussed at the very end, just identified these as problems that need solving. I wrote up notes in a markdown document, so I'll send that around. Chris.
So I see that you get streaming behavior and sort of one-shot maps, right? Because these aren't replicated processes.
Right, so this is one shot. You put an exclamation up front, you get replicated. This is sequential from a fixed data type.
Okay, so you would make an array-like thing by replicating that up. Not the for, but yes, that. Somehow. Each of those need to be replicated, right? So you could add index 0 to index 0.
Yeah, so once this has been sent over the network, then it is a name and can be destructured and accessed as many times as you want.
Okay, so you could use it either way.
Yeah.
You just, okay, that makes sense.
Sorry, for the camera, this, once it's been sent over a channel, the for that gets it as a name and can do matching and destructuring and use the destructured pieces as many times as they want. It's not necessary to pull this in each key linearly, right? And use it only once. One of the other things we talked about that was related to economics but didn't get talked about here was the difference between the dynamic and static. Now with static, it is hard to know in advance how much something is going to cost. It's frankly undecidable. So the question is, how do we design, I mean, Joe and I have been pushing Greg to include a total functional sublanguage. Arithmetic expressions is an example of that sort of thing, but more. There's the Simplicity white paper that came out just last week about a bunch of combinators for total functional programming. We think if we include that, it will make estimating the total cost much easier because you know that it's straight line code and going to finish. So in as much as you can use it, it will make the estimations easier. In the case where we have parametric costs, that the cost is, say, you send me a message of size n, it's going to cost n squared to run this thing. That is also a useful response for how much is this going to cost, so that the contract author can say, well, I'm expecting this sort of traffic, so I'm going to provide this much rev to cover it. I know what kind of messages are coming in, therefore I can estimate how much it's going to cost, even if the estimator doesn't know anything about my traffic. So all of these are different kinds of costs, different ways of doing static estimation of costs. In the end, the only thing that's guaranteed to work is the dynamic cost, but then we also have to think about a transactional model, and we need to think about how that interacts with oracles in order to not violate security invariance in the contracts. And now we are out of time. So, yeah, Ed, I guess we have 1 minute left.
Just a quick question. This is especially once you get rolling up at the user contract level, that the cryptographic signing and signature checking seems to be such a common thing, and it's actually relatively expensive compared to some of these other math. Is that going to be in the type system? Is there going to be something like, you know, an address and a private key and a signature?
I think it should be application dependent, in that if you are getting consensus about a particular result, and that establishes the integrity of your message, if you don't need secrecy, then you may not need the hashing. If, on the other hand, you are implementing a communications framework on rchain and storing messages permanently in the blockchain, so for example, you're publishing transactions to the blockchain that are encrypted to establish credit over that corpus later, then you certainly want that. And I think that providing cryptographic primitives at some level, whether by a service that you're interacting with, or that we standardize on something in the nodes, is an excellent idea. But if it were standardized as part of the nodes, I think it would be like these other ports, you know, TCP or HTTP. You'd have a crypto service that you're interacting with directly at a system contract level, and then how that gets exposed to the user contract level may be similar to oracles, or maybe we expose those directly to the users. There's any number of possibilities in that arena that we have to think about and decide on.
And just if I could, Ed, you asked about how typings kind of played into the system. Well, to kind of connect back what Greg was saying about port versatility, it's that channel typings actually play a big role in how we would estimate the cost, because considering the components I laid out before, whether the cost of sending, you know, the cost of sending something can be the cost of putting something in storage, it can be the cost of putting something in memory, or it can be the cost of putting something out on the network, right? So typings for channels in that way would inform how we actually cost the send statement, for example.
Yeah, but I think so like in order to implement Casper, we're going to have to be able to sign messages, and yeah, and so those primitives.
So that is an argument for putting it in at the system contract level.
Yes,
Right.
Exactly.
Don't nodes need to sign for authenticity?
Yeah. That's That's correct, right? Yeah. So, well, no, but I mean, arguably you could implement that lower than.
So,
but what we're talking about is if we're doing most of the consensus algorithm in Rolang, then that means that the cryptographic primitives should be available in Rolang. End of story, right? Yeah.
Okay.
Yeah.
Yeah. So we have to think about which crypto primitives we're going to expose, as well as a transition plan for when those crypto primitives reach end of life.
Yes,
Right.
exactly. That's right.
Because they are always being broken. The attacks only get better. So we need to have a way of transitioning over. We need things like forward secrecy. We need a whole bunch of stuff. Key management. All of that needs to be thought through.
No one's ever solved that, right? No. All that stuff is actually pretty solved. And we understand quite well how to rotate keys, signature algorithms, hashing algorithms. We understand like replication, recovery, like. Yeah, absolutely. We know how to change digital signature algorithms, hashing algorithms. It basically requires that you change them before they break, however.
Which almost never happens.
No. On the contrary, you can see the progress of cryptanalysis. And unless there is a real big breakthrough, historically it has been the case that you increase it by a few rounds, you increase it by 10 rounds, you increase it by 1. You start getting close and you're like, man, this thing's going to break any day now. We ought to switch it out.
People find vulnerabilities way before they find exploits.
Yeah. At least with cryptography, right? You don't get papers that completely break something. You get incremental improvements.
Yeah, they're like, okay, upgrade your SSL. Get rid of that SSL. Get rid of it!
So actually, yeah, and it's also like a problem with like governance and upgrading and making sure that people actually make the move as opposed to actually the technical issues, right? Like,
Right. I just meant a list of crypto primitives,
And
It would be hard to notify people anyway. Like you get notifications when your password's about to expire, for whatever online banking thing. I don't know. You know what I mean?
Oh, I see.
But just one more type, quoted process. We have to have a type here for, in the simple sorting, for knowing when we can dereference it. Yeah.
Exactly. So you have to know when you've got a pointer.
And now we're 5 minutes over time, so I'll turn the time back over to whoever's in charge.
Yeah, that's right.
The reflection comes from the quoting. Higher order comes from the fact that you can send the process. Okay. Instead of just the thing.
Yeah. It's actually really interesting because if you look at what, like the initial proposals for higher order processes, rather than considering this reflective idea, they literally had two different kinds of variables.
Process variables and name variables.
Process variables and name variables. So you had twice as many moving parts, and it was twice as hard to reason about. Chalks was just a nightmare to reason about. Is that it for today?
Let's see, what's on the schedule? Treat schedule cocktails, 4:30 to 5:30.
And then the real work.